question, I think. That's better. Yeah, okay. Alright, so let's first quickly look at this. Distance is speed into time, right? So first thing, if I say that speed is a constant, that means what? Distance is directly proportional to time, isn't it? So two people, let's say two persons A and B, both travel at 10 meters per second, for example. One travels for 20 seconds, the other travels for 5 seconds. The distance this fellow covers, B, obviously A will cover 4 times the distance, isn't it? Because A travels for 4 times the time here. So this we say that distance is directly proportional to time. Okay. In the same way, if the time travel is constant, there's a second point here, the distance will be directly proportional to the speed. So think of two friends who have been traveling for the same time, but one travels at twice the speed, will obviously cover twice the distance. So distance is directly proportional to the speed. Okay. Finally, the most important one, if the distance is constant. So again, let's figure two people, A and B, have to cover some fixed distance. But A travels at double the speed. So obviously, A will take half the time. Okay? A travels at double the speed. Hence, A will take half of the time as B takes. So if speed is doubled, then time becomes half. If speed is tripled, then time will become 1/3. If speed is, let's say, multiplied with 2/3, for example, that means speed has reduced. The time will increase and it will become 3/2 times. So you multiply speed with x, the time gets multiplied with 1/x. That is the concept of inversely proportional. So speed is proportional to 1/time. In other words, it is inversely proportional to the speed. Okay, so these are the basic three concepts. Now let us take this question. Okay. I will suggest you see the question, try to solve it yourself. 2 minutes for this. Take 2 minutes for this. Try to solve it yourself. And if you get some answer, just write it in the chat. And then I will show you the method by which we can also solve. Okay. Have all of you tried? 3:2. Okay. I got one answer. One is to 3. Okay. Alright, so now let us see. All of you can see this, right? I am just going to draw a diagram and let's see whether we can answer the question from that diagram alone without doing much extra work. So let's say this is your tunnel here. Okay? And the man is standing inside. This is, let's say, end A and this is, let's say, B. The man is standing somewhere here such that from the end A it is 1/3 of the length of the tunnel. So this, if it is X, then this is 2X. Where the length of the tunnel is this 3X, okay? Now, what else is known? There is some train approaching, okay? Let's say this is your train coming from this point, the T. This is the train T. And the train is obviously some distance away from the tunnel, right? So let us say the distance of the train is D. All of these are unknowns. D, X, whatever. Okay. Now what does the man calculate? This is important. If the man runs to this end, the train will just reach this point. That means we know that the man and the train will reach point A simultaneously. In the same way, if he runs towards this end, B, then the man and the train will reach point B also simultaneously. This is what we know. So now think if the man is running towards point A, then how much distance does the man cover? Covers X. And in that case the train covers how much? The train covers D. That's what we have in the diagram. If the man covers this distance X, the train covers this distance D. Now, imagine the man is traveling towards B instead. So the man will travel this distance 2x, isn't it? So, to travel a distance 2x, the man must have taken twice the time. See, the man is running at a constant speed, isn't it? So to cover the distance 2x, he would take twice the time as the previous case. So in that same time, in that twice the time, the train should have covered 2D, am I right? If the man covers X, the train covers D. If the man covers 2X, the train covers 2D. Very simple. So conclusion is what? That the length of the tunnel is equal to D. Am I right? See, I am not doing any calculations. I am just observing this. If the man has to travel 2x, the train must have covered 2d. So from here to point B, the distance must be 2d. So 3x must be d, because you already have d from for this part. So as a result, now what can you say? So what is x basically? So x is nothing but d over 3. So now the question is solved. For any one part, if you look at the first point A itself, we can say if the man has traveled d over 3, the train in that same time has traveled d. So obviously the train is thrice as fast. The train is thrice as fast as the man. So speed ratio is 1:3, man to train. Alright, I am repeating this now. Lot of students just now came, so I am just going to repeat the concept once more. See, what I am saying is, this is your tunnel, let's say, and this is the train. The man is standing here in such a way that it is mentioned that he from end A is 1/3 the length. So if I say that from the point where he is standing to A is x, the other point B must be 2x. Only then the total length will be 3x. That means the man is standing 1/3 inside the tunnel. Till here it is fine. Now the question says, if the man decides he will go to this point, the train will reach this point at the same time. This is the first point that is being said. The second thing that is being said is, if the man decides he will go to this end, the train also reaches this end at the same time. This is mentioned in the question over here. If he runs to either end of the tunnel, he would just be able to escape alive and not be run over. That means he will just cross the tunnel and the train would cross at the same time. So now what is the logic here? My logic is very simple. If the man travels x, the train travels d. Both are unknowns. I am not bothered with how many unknowns I am looking at. I am just looking conceptually. So if the man travels x, the train travels d. So if the man travels 2x, the train must travel 2d. The ratio must be maintained because the time is constant. The man and the train reach either end at the same time. Time is constant. So if this distance is d and the total distance is 2d, obviously the tunnel length must also be d, isn't it? Once you know that the tunnel length is d, so it's very clear that this x that we were looking at initially is nothing but d over 3. Because the tunnel length we have taken 3x, now we are saying that it is not 3x but it is d. So what is x? D by 3. So why do we stand now? We say that if the man travels a distance d over 3, the train travels a distance d. That means the train must be thrice as fast. And that's the problem. So there is no calculation. Simple concept. Alright? Okay, now let's continue with the presentation. So we are done with this. I hope you are clear with this. If you are not clear, then you can always mail me your doubts and we'll take it up from there. Okay. Now the next concept, before I go to the next concept, okay, now this is the concept what I am saying is time is universal. What do I mean by that? Time is universal. The time on your watch and the time on my watch will be the same. Always. Provided we are in the same time zone. Okay. So the time on our watches are the same. So time spent is equal. So if I say that I have worked for 2 hours So from 12 to 2, when I spend the time from 12 to 2, you also spend at the same time 12 to 2. What I mean by this is, let's look at this problem and let us say you answer, try to answer this. There is no concept involved of, do not try to use relative speed or average speed or any other thing. Just simply use speed and time multiplied to give distance. Have a look at this problem. This is pretty interesting. Then I'll explain the solution. And I expect a lot of answers to this one. One minute 40 seconds. Okay. 150. Okay. 100. Okay. Good. Okay. Keep on. Someone has already given the answer. Correct answer. That is. Okay. Now let's see this. How to tackle this one. Okay. Let's draw. Okay. Remember, in time, speed, and distance problems, it is best if you draw something. It gives you a very clear idea about what is going to happen. So this is the route, okay, let us say, and this is x traveling and this is y traveling, okay, towards each other along the same route, okay. Every day they meet at a point P. Let us say this point is P here. Remember, I do not know where they start from, like where the x starts from, where y starts from, nothing is mentioned. I only know that this point is where they meet. Since they meet always at the same time, it means that they are punctual, right? So if X, let's say, starts off in the morning at, let's say, 6 o'clock in the morning, and Y starts at 6:15 in the morning, let's say, for example, and every day they start at the same time, every day they move with the same speed, so obviously they will meet at that point P every day at the same time. Okay, so let us say they meet every day at 8 o'clock in the morning. Let's say 8 o'clock in the morning. Let's take some random time. Okay. Now what has happened on that day is X is late. So obviously the meeting point will shift towards X, right? Because X will have covered less distance. Hina, you have asked the question that the same time doesn't mean both start at the same time. No, we don't know when they start, okay? They maintain their times, okay? That's what I mean. So if X starts at 6 o'clock, then every day he will start at 6 o'clock. If Y starts at 6:15, then every day Y will also start at 6:15. That's what the question is saying. I do not know where they start from. I do not know exactly at what time they start. But what I know is they maintain their schedule. So if they maintain their schedule, they will meet always at a particular point at a particular time every day. That schedule will also be maintained. That's the concept in the question. Now see, Q on that day, X was late by whatever the time he was late. So obviously X will be behind schedule. So Y would have crossed P and moved on and met somewhere at point Q. Met X somewhere at this point Q. This is given 600 meters. Now, obviously Y was not late, isn't it? So can I say the first point, Y reached P at 8 o'clock again? Because he is going to maintain the time. Obviously Q did not. X did not. But Y reached P at that point. But Y has to cross over, and Y is traveling at what speed? Y is traveling at 6 meters per second. So Y will reach Q. How long will it take? Y will take 100 seconds, right? To reach Q, because distance is 600, speed is 6. So the time taken is 100 seconds. So that is 1 minute 40 seconds is when he will reach at point Q. So what will be the time there? It will be 8:01:40, right? 1 minute 40 seconds past 8 o'clock. This is when Y reaches Q. Now this is where I say that time is universal. The point that X and Y meet at that point Q implies that X reaches Q also at 8:01:40, isn't it? Because I am saying X and Y are meeting at point Q, so the time on the watch of Y and the time on the watch of X must be the same. So if Y reaches at 1 minute 40 seconds past 8, then X would also reach Q at 1 minute 40 seconds past 8. But the point is not that. What is the question? The question is, how late was X that day? The question was how late X was on that day. So X reaches here at this time. So when will X reach P? That will give you the measure, right? Because X used to reach P at 8 o'clock. Today, when does he reach P? That is the main question. So how long will X take to cover that 600 meters? X is traveling at 100 meters per second. He will take 60 seconds. That means 1 minute. Okay, X will take 60 seconds, that is 1 minute. So we'll reach P at 8:02:40. So they were reaching at 8, now they are reaching at 8:02. So late by how much? 2 minutes 40 seconds. 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 2 minutes 40 secon Some of you have got the answer. 160 seconds is the correct one. Okay, see, there is nothing in the question. There is no calculation provided you, unless you say that 600 by 10 is 60 is the calculation. Okay, that is, there is no calculation in this question. It's only the concept that you have to understand. All right. No, the Mohit, the question is not about how late he is when they meet. That can never be a measure of being late. Say, if you have to reach office, let's say at 10 o'clock in the morning, and on the way you cross a bus stop at 9 o'clock every day, let's say, on one day you cross the bus stop at 9 o'clock but reached office at 10:15. Getting the point? Every day you reach office at 10 o'clock and you cross a bus stop at 9 o'clock, let's say. On one day you cross the bus stop at 9 o'clock but ended up reaching 15 minutes late at 10:15. Yeah, got it, right? So you can measure late only when you reach the same destination. Alright, so this is fine. Now let's continue with the presentation again. Okay, so this is fine now. The concept of average speed. Okay, so let us explain what is the concept of average speed. So average speed is measured as, we all know that we always say that it is measured as total distance upon total time. Right? This is universally correct. Yes, it is the total distance by total time. But sometimes we get carried over and say, don't ever by mistake take the average of the speeds. We do say it, right? Sometimes if someone explains to you average speed and they say that if a man travels a distance at 40 meters per second and then travels some other distance at 60 meters per second, we have often heard this, I don't know whether you have, but I have heard it very frequently, that don't ever calculate average speed like this. This is wrong. Isn't it? How many of you heard it? That this is wrong. You have to do total distance, find it, then calculate the time taken, and then divide them and get the answer. Now my question to you is, can I ever do this? Can I ever do this? Okay, Akshay, you have said yes. Okay. When can I do this? Can you just type in your... No, you're wrong. When distance is same, you cannot do this. Okay, Neha, you are saying you cannot do this at all. Akshay, your answer is wrong. It is not when distance is constant. If distance is constant, you cannot do this. Yeah, right. Good. Time is constant. Yes, Neha, your answer is not right. You can do this sometimes, okay? Take this case. You travel, let's take an example. You travel, let's say, 100 meters at a speed of 10 meters per second, fine? And then go on to travel 200 meters at 20 meters per second. What is the average speed? So we will do 100 plus 200 total distance, 10 plus 20 total time. We would get 300, oh sorry, I forgot to calculate the time. So the time in the first case is 10 seconds and the time in the second case is also 10 seconds. Here it is 10 seconds, here also it is 10 seconds. So it is 15 meters per second, which is nothing but 10 plus 20 upon 2. The speeds 10 plus 20 upon 2. So I will discuss 2 points here. Number 1, if the distance is constant, so you travel a distance, let's take a smaller value, so 60 meters at 10 meters per second, and again travel 60 meters at 20 meters per second. So we are saying distance is same. 6 seconds is the time, 3 seconds is the time. So our average speed will be 60 plus 60 upon 9. So 13, 1 upon 3 meters per second. Instead of doing this entire calculation, we could have simply done 2 times the product of the speeds divided by sum of the speeds. So that would be 2 times 10 times 20 upon 10 plus 20. So that would be 400 upon 30, which is 13 1 by 3. Remember this. So when distance is constant, the average speed is twice the product divided by the sum. This is the first special case. The second special case is what we already discussed, that time is constant. Then the average speed is simply S1 plus S2 upon 2. This is the second special case. Okay? This is the arithmetic mean, whereas this is the harmonic mean. Okay? So every time you come across an average speed question, don't keep on finding distance and time and all that stuff to calculate. You can use shortcuts like this. Okay? So now let's look at an interesting problem. What is the answer to this? Okay, Neha, you have answered 60. I'll tell you one thing. Here distance is same because you are planning a return journey. You still want to stick to your answer? Okay, good. Forty. A sir, you have answered. A sir. You are saying you return at 40 and the average for the entire trip will become 40. How is it possible? Your onward journey was at 20. Your return is at 40. So the average will always lie in between the two values, isn't it? Akshay, you are not correct. Anyone? Mohit, you are saying 20. How is it possible? Think when you are answering. are covering a distance at a speed of 20, you are returning also at 20, so won't your average speed remain 20? Think logically, okay? Don't think of maths. Think logically. You are going at 20, returning at 20. Your average speed remains 20 only. There is no change in the speed at all. I want the average to become 40. Double. Okay, let me explain this. As I said, draw a diagram. No, Hina, 80 is not right. Draw a diagram. Distance, this is the point from A to B you are traveling. Onward journey at 20 miles per hour. Let us say return journey is x miles per hour. Is the distance constant? In both cases the distance is constant, right? You are traveling AB, you are returning BA, so the distance is the same. Therefore the average speed according to the formula I just gave is twice the product of the speeds upon sum of the speeds, isn't it? So according to the question, this average speed is 40, right? So twice of 20x upon x plus 20 is 40. See, 40 and 40 cancel, cross multiply, what do you get? What does this mean? Is it possible? X is equal to x plus 20. Yes, it is possible when x becomes infinite. Isn't it? With infinity you add 20, there is no change, it remains infinity only. So that means what? If you have to make the average speed 40, you have to travel at speeds higher than the speed of light as well. Because light has a finite speed, 3 into 10 to the power 8 meters per second. You have to cross that and move. So that means this is not a possible scenario. It's not possible. Interesting, isn't it? You cannot simply make the, no, you're wrong, it cannot be determined is wrong. You can determine the answer. The answer is the question is not possible. Cannot be determined is entirely a different concept. That the data is not sufficient enough to answer. That means cannot be determined. Given some more data, you could have answered the question. That is what it means cannot be determined. Okay. But this you can determine the answer. You can determine the answer perfectly. And the answer is it's not possible. So isn't it funny that you cannot make your average speed double if you travel the same distance again? So if you cannot make double, then you cannot make triple, 4 times or anything of that sort. Okay. Anyway, so this is the concept of average speed. Now I will end the session with one last problem. Okay, one last problem. This one. Let's see, all of you try and solve this. Neha, 500, I don't think 500 is correct. I don't think 500. I don't remember the answer though, but I feel it is 700 possibly. Uh, Speed is constant as in you want to say whether the boats have the same speed. Again, see logically, Neha, I am replying to your question. Logically think if if it were the case that their speeds are equal, wouldn't they have met always at the midpoint? Am I right? They would always meet at the midpoint. In that case, if distance from x is 300, distance from the other point is also going to be 300. So the total distance would be 600. Yeah, okay, fine. Forget the river flow. I'm saying if you are meeting first case you meet 300 meters from one end, then the other fellow would have also met 300 meters from his end, right? That means the total distance would become 600. Now after they cross, they will reach the opposite banks at the same time. Again they start going towards each other. They will meet midway. Then in the second case, they should have met 300 meters again, isn't it? From either end. But now they are saying it's 200 meters. That means what? Obviously, the two boats have different speeds. Obviously, the two boats have different speeds, but yes, they maintain their speeds always. So if the speed of x is, let's say, some 200 meters per second, then it will remain 200 meters per second throughout. Okay, I'll give you one more minute. And then I'll solve it in two different ways. Rudra, 700, good. Okay, so your 1 minute is almost up. Let's see the solution, okay? We are going to use whatever we have learned till now. Nothing special in the question. Okay, I use two different colors for the boards. Let's say P is black and let's say Q is red. Okay. So Q is moving this way and P is moving this way. So the first meeting happened 300 meters from P's end. So let us say this point. Let us say this is the point where they meet at X. And this distance is given 300. Now after meeting what happens? P continues. I am tracing P with a black ink, okay? P continues and immediately turns back. After reaching the end, immediately turns back towards his initial end, okay? That is given in the problem. What does Q do? Q also continues. I am tracing it with a red ink and immediately turns back after meeting towards his initial end. This is Q's path. It is mentioned that they met for the second time at a point Y 200 meters from Q's end, initial end. Q's initial end, okay? So this is 200. So this data is known to us. And they meet in opposite direction is also mentioned here. That they met in opposite directions. The second time as well. Now let's look at the traditional way of solving. Let us call the distance to be d. That's what we usually do. That's the unknown. We'll take the d as the variable. So what is the distance traveled by first meeting? So for x I am doing. Distance traveled by p is how much? 300. Distance traveled by q is how much? D minus 300. Is it okay? This is d minus 300, this part. For y I am now saying distance traveled by p is how much? From the beginning only, let's say. P traveled all the distance, entire distance PQ and turned back 200. So distance traveled is d plus 200. What is the distance traveled by Q? Q traveled all the way the entire distance PQ, that is d, plus if this portion is 200, then the remaining distance is d minus 200, isn't it? I am saying this is d minus 200, this part. All of you are okay with this? From here, therefore, can't I say that since P and Q maintain their speeds, and they meet, that means what? Time of travel. The time for which P and Q travel is always the same. So obviously the distance ratio must be equal to the speed ratio. So can I say that the speed ratio of P and Q is 300 upon D minus 300 as well as D plus 200 upon D plus D minus 200. Can I say this? The ratio of the distances P and Q travel will always be the same. Now the question comes that we have to now solve this. Looks very complicated, isn't it? D's are there, lot of D's are there, we'll cross multiply, we'll get a quadratic equation, we'll factorize that and do a lot of things, and we'll spend 5-6 minutes to do that alone, and we'll finish the problem after that. We don't have so much time. Okay? So what can we do? Have you heard of something called componendo dividendo? That if A upon B is equal to C upon D, it clearly implies that A over A plus B must be C over C plus D. It's a very important property of ratios. We'll use that. How? Very simple. Okay, Hina, what are you saying? Why are we taking the ratio? Okay, see, I have got the distances of P and Q, isn't it? My point is, distance is directly proportional to speed, isn't it? So distance of A by distance of P in this case by distance of Q will always be the speed of P by speed of Q. I have to frame an equation to solve for D, isn't it? So how do I make the equation? I'll use this property. I will say that the speed ratio is the distance ratio in either case. In the first case for the meeting point at X, and in the second case as well. Okay. So this is what I was doing. I equated the ratio of the distances. Now I am using this property. So what I do is I'll keep the 300 on top and add these two. So I'll get D. I keep the D plus 200 on top and I will add these two using this logic. And so what will I get? I will get 3D. The 200 will cancel out. Now see what happens. The D cancels out simply and I get 900 is equal to D plus 200. So your D is 700. So you don't need to cross multiply and frame a quadratic equation and then finally solve it. Okay. This is a shorter way. Later on, maybe if you, okay, we don't have so much time tonight. We have to stop at 11. So what I'll do is on Saturday, if some of you are there, those of you are there for the Saturday session, we'll take up this problem and I'll show you a method by which this can be solved without doing anything. Just I'll draw the diagram, which I have drawn already, and I'll simply get the answer from there. I'll not do anything after that. No equations, no variables, nothing. Okay, I'll show you that method on Saturday because now we are running out of time. Okay, so let's stop the problems here. Yeah, so we'll not be able to finish in 3 minutes. We'll not be able to finish in 3 minutes. We'll take some questions now. Okay, so this is what we were planning to discuss. Okay, so what is going to be on Saturday? What we have on Saturday? So see, there are going to be a batch. There's going to be a batch. Okay, and there will be 7 seats for that batch. The session will be on 2 hours on time, speed, distance. It's not as if that we'll finish definitely within 2 hours. If not, we'll take one more session of time, speed, distance if required. That depends. We'll cover the concepts. We have already covered a few of the concepts tonight. We'll cover the remaining concepts of relative speed, upstream, downstream, circular tracks on that day. And we'll cover cat level and even tougher level problems, and we'll show how questions of time and distance can be solved without making big equations. Okay, so that is what we are planning to do on Saturday. This Saturday, that is. The timing will be from 2:30 to 4:30. The pricing is mentioned below so that you can always discuss with Spanidia. Alright, this is the idea. I'll just introduce myself in case you don't know me. I am Sujoy Datta, and I am into CAT and GMAT, GRE and all that training. I have been training for the past 9 years almost. I have taken the CAT 5 times, 2008, 9, 10, 11 and 12. I secured a 99 above percentile, 99.5 around each of those 5 times. Okay, I am going to take CAT again this year. The last 2 years I have missed, so I am going to take it this year again. That's fun basically, I just take it for fun. So this is roughly my profile. Okay, so those of you who are interested can now ask questions. You can unmute if you have any doubts. You can just type it also. Okay. No, don't worry. I don't fill up the colleges. Like, you get a call only if you fill up the college lists, right? Which colleges you want to apply. Keep it blank. I am also just kidding. Okay, just letting you know. Okay. All right. Thanks for attending the session. Then it was nice meeting you guys. So hope to meet some of you or all of you maybe on Saturday. All right. Skype account. Okay, fine. I'll do one thing. I'll give you my email ID. Or okay, fine. You take my Skype account. SK_Datta. Okay. Okay. Bye then, everyone. Good night, everyone. Okay. Thank you. Bye. Bye.